Good morning, friends. Today we are going to discuss about reverse engineering and tool support. So, first of all, we are going to study about what do you understand by reverse engineering. Reverse engineering is the process of analyzing a product or system in order to understand its design, internal working, and functionality. Reverse engineering is often used to gain a better understanding of product or system in order to improve it, to create complicating product or system, or to identify and fix flaws. What do you understand by reverse engineering? It is commonly used in fields such as software development, manufacturing, and security. However, reverse engineering can also be used for malicious purposes such as stealing trade secrets or creating products. For this reason, reverse engineering often regulates by law governing intellectual properties and trade secrets. How does reverse engineering works? Reverse engineering is the process of analyzing a product or analyzing a system to understand its components, functions, and operations in order to understand how it's work or to create a copy or imitation of it. Reverse engineering reverse engineering is used to identify weaknesses in the system, create compatible or alternative version of the system, and improve upon the original designs. The process of reverse engineering typically involves disassembling a system or device to understand its components and how they fit together. It can involve taking apart devices or analyzing the code and structures of software system. However, it is important to respect the intellectual properties rights of others when using reverse engineering and to only use it for legal and ethical purpose. Reverse engineering in security. Reverse engineering. The purpose of reverse engineering in security is to identify and mitigate potential vulnerabilities in the product or system. This is typically done by examining the product or system design, code, or components in order to understand how it's work and identify any potential weaknesses. For example, a security researchers may use reverse engineering to study the design of a software application in order to identify any potential vulnerability that could be exploited by attacker. This could involve examining the application's code, analyzing its network communication, or studying its interaction with other system or components. Steps in reverse engineering. Reverse engineering typically involves the following steps. First, identify the product or system to be reverse engineered. Second, collect information about the product or system. Third, analyzing the product or system. Fourth, creating a model of a product or system. Fifth, use the knowledge gained in reverse engineering. First, identify the product or system to be reverse engineered. This typically involves identifying the specific software product or a system that need to be studied better to understand its designs, internal working, and functionalities, analyzing the product or system. Second, collect information about the product or system. It involves collecting information about product or system that various sources such as its designs, documents, code, or user manuals. Third, analyzing the product or system. It involves This typically involves analyzing the collected information in order to understand the system's designs and functionalities. This may involve taking the product or systems apart, studying its components, interactions, or examining its design documents or code. Four, create a model of the product or system. This steps typically involve creating a model that accurately represents its designs, internal working, and functionality. This model can they be used to study the product or system in greater details or makes a change or improvements. Fifth, use the knowledge gained and reverse engineering. Once the model has been created, the knowledge gained from reverse engineering can be used to improve the product or system, create competing products or system, or identify and fix flaws or vulnerabilities. They, this may involve changing the product or system's design, code, or components, or developing new products or systems based on the knowledge gained. Now we are going to study about tools used for reverse engineering. Here, here are few tools used in reverse engineering. First, Kidra. Second, Androcard. Third, Emacs. Fourth, Red 2. And fifth, IDA Pro. First, Gidra. Gidra is a free and open source software reverse engineering (SRE) suite for tools developed by the National Security Agency (NSA). It is used to disassemble, decompile, and analyzing binary code. Gidra was designed to be a robust and scalable SRE tools, and it is used by both government agencies and broader SRE community. This tools this tools was made available to the public in 2019, and it can be downloaded and used for free. It has a user-friendly interface and modular design, which allows user to customize the tools to meet their specific needs. Additionally, Gidra includes a decompiler and that can convert assembly code into a high-level language such as C or Java, which can make it easier to understand the functionality of a binary code. Second, Androcard. Androcard is an open source toolkit for reversing and analyzing Android applications. It is written in Python and can be used to analyzing the structure and behavior of Android apps. Androcard and includes a variety of tools for performing different types of analyzing, including disassembling, decompiling, and Android apps. It can be used to analyzing the code of an app, extract its resource, and identify the potential vulnerabilities. Androcard is widely used by researchers and security professionals to analyzing the security of an Android app. It offers a variety of features for reverse engineering, includes support of multiple file formats, the abilities to perform static and dynamic analyzing, and integration with other tools such as IDA Pro and Threaded. Third, third, Hamex. Hamex is a ham editor. This is a type of software that allows user to view and edit the raw binary data of a file. Hex editor can often used by programmers, security researchers, and after and other technical users to examine the content of a file at low level. They are particularly useful for analyzing files that are in binary format, such as executable or other types of compiled code. Hemex is a free and open source hex editor. It is available for Windows and Linux. Right. It has a user-friendly interface and a variety of features that make it easy to use. Some of the key features of Hamex include support for large files, flexible search and replace functions, and ability to compare files side by side. Hamex also allows users to define their own data types, which can be useful for examining specific types of data within a file. Fourth, Red Hat. Red Hat 2 is an open source reverse engineering framework that is used for disassembling, analyzing, and debugging binary files. It is written in C and is available for a wide range for platforms, including Windows, Linux, and Mac OS. This tool is widely used for researchers and security researchers for a variety of purposes, including reverse engineering, analyzing, and forensics. forensics. It has a command line interface and a powerful scripting engine that allow user to automate complex tasks and extend the capability of the tools. Radar 2 also include a disassembler that can be used to convert binary code into human readable assembly structures, making it easier to understand the inner working of a binary files. And the last is IDA Pro. IDA Pro is short for Interactive Disassembler Pro. It is a commercial disassembler and debugger. It is that is commonly used for security researcher analyzing compiled code. It can be used to reverse engineering executable and other binary files. It also offers a variety of features for static and dynamic analyzing, including support for multiple architectures and file format. The ability to create and modify disassembly and integrating with other tools such as debuggers and decompilers. IDA Pro supports cross-platform compatibility and also offer a graphical user interface as a graphical user interface as well as a scripting language for automating complex tasks. It is considered one of the most powerful and feature-rich assemblers available, but it is also known for its step learning curve and high prices. High price. Thank you.